Hey everybody, I am Francisco. I'm here to talk about data infrastructure and how it's evolved so quickly over the last 10 years. I'll get right in. So I'm Francisco. I'm a tech lead manager for data and machine learning at Fast. We're a early stage venture backed company focused on a one-click checkout for the internet that obviously requires a whole lot of data to be able to solve that particular problem. Um, I've worked at places like Goldman Sachs, the Commonwealth Bank of Australia, AIG, Ipsos, all within the data and machine learning space. I have graduate degrees in data science and machine learning and economics and statistics from Columbia and Clemson University. Um, and, I wanted to give this talk because over the last 10 years, I've seen how dramatically um, this infrastructure and the way we do data and analytics has changed. We've been doing data and analytics for really, probably 40 or 50 years. And, it's always been really, really evolving. But over the last 10 years, it's been quite extraordinary. And so I thought that it'd be fun to give an entire talk about that. So there are going to be really three things that I'm going to talk with you about today. The first of which is incorporating an SDLC, a software development lifecycle, into data science. The second is robust data documentation that enables data democratization. And the third is investing in tools that help you build, ship, and deploy data products faster. And then lastly, at the end, we'll leave some time for some Q&A, as well, in addition to Q&A throughout the presentation today. So again, over the last 10 years, the way that we did distributed computing, statistical machine learning, and building, all of the infrastructure around it has changed pretty dramatically, right? If I think about what this looked like, or what this line of work was like 10 years ago, folks would have, maybe Oracle databases, SaaS servers where they would extract that data from that production database into some sort of offline analytical database. Maybe it was like a SQL server or something, using, again, like a SaaS cron job to just run a batch job every hour or maybe every day to pull the data, store it in CSV files or in the database properly. And then people would do the kind of traditional extract, transform, load into whatever kind of reporting tables or analytical tables that they had. And then HDFS came out, and distributed storage became a really kind of novel architecture. And then we started using things like Hadoop and Hive and MapReduce to actually do arbitrarily scalable operations on that kind of distributed data, right? And then we found further that we could enhance the performance of that by adding more compute, right? And then things like Apache Spark came out. And then now we're seeing an evolution further into things like, Apache Beam and Flink and infrastructure to help support lower latency time and operation and kind of this hybrid between offline, online systems, all to further enhance consumer and product experiences, all powered by data. And so kind of the top level question is, well, how do you keep up when all this data and machine learning infrastructure has changed so much, right? And I spent most of the time talking about the data, but even the way that we do numerical computing has changed dramatically, right? It used to be the case that you would use SAS for much of your statistical computing, and then people started moving more towards R and then Python. And then again, they started to find that there were some challenges with that, and doing in-memory computing is expensive. People moved again and used libraries like MLlib to really do arbitrary scale. And then GPUs kind of got thrown into the mix. And then people have started to build their own custom hardware like Google and Intel and all these other chip and NVIDIA, all to kind of facilitate high performance distributed machine learning. So again, this entire ecosystem of data and compute has really, really changed quite dramatically. And so again, how do you keep up with that, right? And even anecdotally for us at Fast, we've been alive for really about a year, but in approximately 2 years, we've created over 500,000 lines of code, right? Probably twice that if you think about diffs. We have over 80, I guess now, engineers. We have, probably more like 50 data pipelines at this point. And that's tremendous, right? Because there are organizations like that many of folks might be working at that probably have 10x this, right? Or 100x this, right? Especially organizations like IBM or SAS, and it's just constantly evolving. Data is being generated, right? Super fast. I mean, that's kind of the core of Moore's law. And so, again, really trying to harp on the point that everything is changing and we just have to keep up with it. And so the first thing I'll talk about is incorporating an SDLC into data science, because it's one of the kind of most interesting parts of the work that I saw throughout my career. And again, I've only been working a short time, but I do feel that this was an interesting phenomenon that I saw, and then I thought it was pretty exciting to talk about. And so, what I'll say is, with data science, you have to define your North Star, right? You want to make sure that you can thoughtfully develop processes, tools, and architecture, ultimately to help you build and ship faster. I particularly like the software space because it gives us the opportunity to really be impactful, to be helpful, and create really great experiences. And so for us at Fast, and for me personally, I like building infrastructure and systems that help people just move quickly and operate effectively. And so that's kind of the core North Star for us, right? And so as an organization scales and data becomes more complex in it, that North Star gets harder and harder to reach. So defining that at the start and up front really helps me focus on what problems are going to be relevant and what problems are going to be a distraction, and how to make sure that we're properly solving micro problems in a kind of macro way, right? That aligns with the strategy that we have. And so that really leads with starting with the end game, right? And what I mean by that is that, have a very concrete picture of what the end result of your experience, your product, your deliverable looks like. And sure, that can be contextualized in a slide, but it's probably better represented in the product experience, in an API, in an understanding of how that interacts with the customer. But find out what that end game is. As a concrete example, we recently launched recommendations, and we spend most of the time not on the machine learning side, but really on developing all the infrastructure around it to support the deployment of it. Because we know that ultimately there's an endpoint, the model, right? And then everything else in between and all the data that has to get connected and intertwined, will shift, will get richer and more thorough over time. So really start with the beginning and the end, and then figure out the middle. At least that's kind of how we approach it, right? And then treat your model development as code. This isn't a super contentious point, but it's one that strangely I feel like has to be said, because throughout the organizations I've worked at, it hasn't quite been treated with the same level of rigor. And so, when you're doing model development or feature engineering or model scoring, that model is, and that process that you're doing, it's not just some quick analysis, it's actually code. And if you're doing interesting work, hopefully you are, that code will eventually be put into production. And if that means that it's going to be put in production, that means that you should treat it as really important, as a core part of whatever process you're working on. And so that's not to overdo it, right? Because there's a lot of infrastructure and tooling now built out to help enable scientists to go from, code or like Jupyter Notebook to model deployment, and that's great. But there's also thoughtfulness that has to be done, right? Because I've written features myself where a simple division by zero would.
We appear to have cut out.
Your models are versioned. What's that?
I think your
Hello?
mic cut out for the past few seconds. Could you repeat the last 30 seconds, please?
Yeah, of course. So yeah, just treat your model development as code, right? Ultimately that the Jupyter notebook to production, there's steps there. And in my own experiences, I've created features that a simple division by zero could completely destroy. And so you want to be thoughtful about how you're doing that feature engineering, making sure that it's adequately tested and that you're thoughtful about it, so that when you go to deploy it, it's very successful. And then your models are versioned artifacts. What does that actually mean, right? You could consider your model to basically be an API. It's an endpoint, right? And if it's an endpoint, then you want to make sure that when you change it there. And so you want to make sure that you're thoughtful about the deprecation of it, about the change management of it, so that again, all the other stakeholders surrounding that aren't impacted, and that a simple all models degrade, monitor them, right? All models have a half-life. Depending on the type of model, it might be very, very short. If it's a fraud model, for example, I've spent a lot of my career in risk. Fraudsters are intelligent, they learn quickly, and then they adapt quickly. And so you always have to be conscious of hey, this model is with probability 1 going to degrade. How do I make sure that I have systems in place and checks in place to monitor that degradation and allow for either an automatic deployment or a manual deployment to upgrade them and enhance them? And so that's a really, really important thing to make sure you do that work and that kind of have that thoughtfulness up front. Because oftentimes within the model development lifecycle, I've seen that's one core step that's often forgotten and said, well, that's some other person's problem, so we don't have to worry about it right now. But that tends to be a pretty big piece of it, right? There's just this. So in summary, data science and modeling and machine learning is very much like software development with an additional step. Additional step is making sure that once your code's in production, that there's the intention of replacing it probably within a shorter time horizon than you would an API. And so now I want to talk to you next about robust documentation to enable data democratization. This sounds maybe a little bit boring maybe for some. I actually think this is probably the most important thing that I'll talk about today, because really some of the challenges I've seen at large organizations, kind of reduced to this particular problem. And so what is that robust data documentation? Ultimately, it circles down to transparency. The transparency is really important. So the natural question is, well, why is it important? It's important because it allows users of all skills to dive down the rabbit hole of data and empower themselves to solve their own problems. I try to be a good colleague and partner in everywhere I've worked and all that I do. And what that means is when someone has a question, you support them, you help them, you enable them to find an answer, right? And in data, that works, but that's also often sometimes a blocker as well. And more importantly, that doesn't scale particularly well, especially if you go from an organization of 100 to a 400 or 1,000. And so you really have to figure out how to actually scalably empower people. The way to do that is make things transparent. Again, make people be able to self-discover. And that's important because ultimately you'll have analysts all across the organization, different functions you might never even hear of, working on reporting, right? And then they could capture a bug and surface it to you, and you can actually work with engineers to resolve it. You can, help structure tables for the intended purpose, right? You can create self-serve documentation and knowledge sharing, so people can just naturally find out oh, this is how this thing works, and ultimately use that knowledge and context to deliver a better product experience and help your stakeholders. And then lastly, and kind of most importantly, you're decentralizing data knowledge. I've worked for many, many large financial institutions, and the common theme that I've heard from them is that like, oh, always find the data person. And it's like this almost felt like mythology, like this data person would solve all my problem. And I realized, in some cases I had to fly to different states, countries to find this data person. And that was a flawed design, right? Because that means that this is not fault tolerant. And as engineers, we want to think about fault tolerance, right? And so if there's a dependency of an entire business or solving a problem by one person, that's not very fault tolerant. And so by democratizing and decentralizing that data knowledge, you empower, all the things above, but also you really help, scale the business in a way that's like, hey, everybody can do their work independently in groups, but again, to be fully self-service. And that's a very powerful thing as you scale. But how do you keep a system transparent, right? How do you prevent those kind of common data silos is what most folks call it. A couple things, right? Used Airflow and Luigi for a long time to orchestrate their kind of directed acyclic graphs or, data engineering pipelines to transform data. And one of the flaws with that is that you could see the DAG files and look at the code themselves, but that's not really right. When you think about data operations and lineage, what you actually are talking about, like a specific column, a specific field, a specific aggregation function, and into a very rich, elaborate graph structure. And so in order to look at that, you really have to question as well, what tools should I invest in, right? Besides Python, R, and MapReduce, and all the kind of silly stuff. And for us, we choose to invest in tools that, again, help us build, ship, and deploy data products faster. And most software products are data products. And so here are some of the tools that we invest in, right? DBT being one of them. And even though that's open source, we spend a lot of engineering effort in kind of maintaining it internally and to enforce it in our code base. We use GitHub. We use PySpark, DynamoDB. We use Snowflake. Snowflake is a wonderful tool in the sense that, as I mentioned long ago, you'd have to go through these really thorough pipelines to pull data, put it into Parquet files, load them into Hadoop, and then schedule a MapReduce job to start processing on it. And it was all very, very intensive. Snowflake kind of abstracts a ton of that. Makes it very easy to work with distributed systems. You don't have to manage an entire like Hadoop cluster, and you can kind of just handle this, right? And then lastly, we also use analytics platforms that separate code from compute and infrastructure. So what does that mean? That means that I am separating the code of what's being processed from a PySpark cluster, as an example, right? And oftentimes at different organizations I've worked at, those things are coupled, right? Like the data engineering team will own the infrastructure, and my team does own the infrastructure, but we separate them in such a way where any scientist or machine learning engineer can spin up whatever compute resources they need. We manage that governance slightly separately. But an analyst or someone who's creating value to the business and building a rich product experience is not bogged down by compute hurdles, right? All they have to focus on is developing whatever it is they need to develop, which is like something like a code or analysis or a data app. And then, we handle kind of all of the rest. And again, the orchestration, the transparent system, and then the compute infrastructure are all completely separated, and we kind of manage them independently. And the intention is by doing so, we reduce the friction of the kind of painful environments to work with that I've experienced in the past. And so what makes a tool the right tool? Well, this is the way that I think about it, how we think about it fast. Does it help me document something? Does it separate infrastructure from business logic, right? Very concretely, if I want to generate recommendations, does that mean that I have to go through all these obstacles to kind of be able to do that? Or are they separated, right? does it manage access controls robustly? We care a lot about security and privacy here at Fast, right? And so I want to make sure that there's the right governance structure and visibility and auditability in place. And so and the product experience we want to deliver, probably not.
Francesco, could you repeat the last
yes.
30 seconds? There was another intermittent cutout for you as well again. I'm sorry.
Oh,
Just
no problem. Sorry
just
about
so
that.
everything's available for the recording afterwards, if you choose to share it, so that people
Yeah,
watching
of
the
course,
recording can view everything. Thank you very much.
Yeah, absolutely. Yeah. So again, we wanted to make sure that it manages access control robustly. That we really care about data security and privacy, and so we want to make sure that we have the right auditability, governance structure, and controls in place to take care of our customers' data. That's really important to us. Does it abstract complexity? Like I said, if whatever tool that we're procuring makes it easier for someone internally to do their job more effectively, that's a very high yield thing to us, right? Because we're a fast growing startup, and moving fast is kind of what we really value, right? And then does it help us deploy faster? What does that mean? Does that mean that things, right? We have finite time, finite resources, and for us, it's really about like that speed to market. That's not true for everybody. Other people have different problems, right? But that's true for us. And then does it meet analysts where they are? One thing that I've noticed throughout my career is that data science has a very broad set of skills. And so sometimes you have like a data analyst who can really cut a lot of code at in SQL, but might not be as strong at Python. And then you'll find a data scientist that really knows Python really well or R really well, but isn't as well versed in PySpark and MapReduce and ETLs, and that's okay, right? But it's important to find tooling that meets them where they are and allows them to be maximally impactful. Oftentimes I've heard things like, well, they should just level up. I don't think that's the right solution either, right? That people have different skill sets for a reason, and we want to accommodate that and then really empower them to be impactful, because that's how we think we can really amplify and enable lots of teams. And so I'll leave you with some closing thoughts, right, to just kind of bring the whole thing together. One, code is code always. Two, high value documentation is a lost cause if not coupled with code. And what I mean by that is I've met a lot of people in organizations with really good intentions, really great analysts who are creating Excel spreadsheets, Word documentation, Word docs, all outlining what the data means, right? But the problem with that is, it gets stale because not everybody is like that really great analyst that spends all that time, right? And then oftentimes, if that analyst leaves or changes roles, then that documentation will become stale. And in fact, in the worst case, that documentation could be negative information, actually be wrong because it's gotten outdated, right? And those are the very concrete things I've seen happen. And so if you couple it with code, you help reduce that risk. I mean, sure, there'll be some hiccups that happen, but because that is the live production of what's actually happening, you can really empower people, again, for the long term. And then make thoughtful architectural decisions. Software and hardware for data and machine learning is constantly evolving. I talked about the last 10 years. Again, SaaS has been around for, I think, maybe 60 years now. The manner in which we are doing compute and data is going to continue to evolve. So figuring out what the right North Stars are is extraordinarily important, because that's going to really just help you scale to achieve the kind of business goals that you want. And then solve problems with the intent of empowering self-service knowledge. As a former, and still, I guess, data person, right, working on the very, very nitty-gritty details of a specific key in a specific field in some random table in a huge mess of tables. Helping those people be successful in traversing that really elaborate graph of structured data and processes is really important, because then you can really help people be more effective and feel like they've solved a great problem. And I know that when I was 10 years my junior and was working on these things, and it was just so hard to find out the data that I wanted or to understand what this thing meant, getting the answer by making things transparent can really make that person's life more enjoyable and help the organization reach its goals, right? Because those things are aligned. I think people are good intentioned. People in the data space want to do good work, but there's often a lot of obstacles in place to interfere with that. And so I think these tools help to empower and enable lots of people to not have to try and reverse engineer some arbitrary report or try to just guess at what this data means. And so those are kind of the key things to think about. Those are the four big items I would say that can really help an organization. Two data folks, we're now at probably about like 30, and our infrastructure has really helped scale us out and launch a lot of data product, and I'm very proud of that. I think that's all because of this kind of structure and framework. And so, if there are any questions, I'd be happy to chat.
Thanks everyone for watching. I'm very sorry for all of the network quality issues that I've encountered. Yes, if there are any questions, please post in the Discord chat. And as a reminder, there's a feedback form for sessions and the entire presentation as it is within the announcements channel of the Discord. And Francesco, is there any other information you'd like to share about you, where they might be able to see your works or your Twitter
please,
handles, etc.? LinkedIn?
Yes. You can find me on LinkedIn, Twitter. Francisco Javier Arceo. If you Google me, I'll probably come up. You can also find me via email, francisco@fast.co. And I'd love to chat. I'm really passionate about this stuff, and we're aggressively hiring. So if you're interested in working some of this stuff, I really mean it. This is, this is an amazing space to work in. It's constantly evolving. I feel like I'm constantly learning. And Fast is an exciting place to get to work in and build out some, the new infrastructure of the internet. So, please feel free to reach out to me. I really would be grateful. And thank you so much to folks at developers for letting me speak here today. Thank you, everybody. Have a happy weekend.